Hi there, and thank you for joining me on this practice set for special cases. And I did abbreviate this title a little bit from the lesson. It just said cubes and grouping because sum and difference of cubes and factoring by grouping seemed like it was getting to be a lot of words on the first slide. Please like and subscribe if you found this video helpful. Drop a comment or question to engage, and check out the many other videos and playlists that we have on the channel. Without further ado, pause the video to work these problems on your own and then come back to check your work. Okay, so these first four don't involve a ton of work. I thought, like, I can get all of them onto one slide without overcrowding it, right? Maybe we shall see. Now, for this first one, we are going to employ grouping. Okay, so when I see these expressions that have four terms, that is one of the options that we have available. So I'm going to go ahead and set that up. And the way it works with the area model is each box gets its own term and it just all fits really nicely in there. And then we have to GCF factor. So I'm going to go ahead and do the greatest common factor between x to the third and negative x squared is x squared. So the x squared is going to come out here on the left. And now the rest of this I can do by multiplying. So x squared times x would give me x to the third. X squared times -1 gives me negative x squared. And x times -3 gives me negative 3x. -3 times -1 would give me positive 3. And so this one would be my base times my height. And this is not factorable. It's not the difference of squares because 3 is not a square. And so that is the end of the problem right there. For my next one, we have, this is a cubes one, okay? And we want to get to the point where if the x cubed doesn't tip you off, at least the if the 64 doesn't tip you off, at least the x cubed does. We don't want to confuse this with x squared like minus 64, which would be a difference of squares. And we're going to use the soap sandwich here. So same, opposite, always positive. Now, if you're watching this and you're like, I don't know what she's talking about, the soap sandwich, like I just was going to click on this video and I did it some other way. Please go check out the lesson that goes with this practice set, especially if you're trying to memorize the formula for the sum and difference of cubes, okay? All right, x to the third power is what gives me x cubed. 4 to the third power gives me 64. And now we're going to square it, smush it together. If you don't know why I'm clapping my hands, again, go watch the other video. We're smushing a sandwich together here. So I'm going to take that x, we're going to square it. We're going to take this, I was going to say the 16 and square it, the 4 and square it to get 16. And then this is my PB and J. X times 4 is 4x. And we are done. Boom. All right, number 3. This is the difference of cubes. And so we'll set that up and we're going to use the SOAP, same, opposite, always positive. All right, again, that's your little acronym for the operators. What I say in the video several times is if you are doing a multiple choice test, stop right here and scan your answer choices to see if you can eliminate answer choices just based off of a misplaced operator. All right, x cubed gives you that x to the third power. 3 cubed is what gives you the 27. And now we're going to square it. One slice of bread, square the 3 to get 9, other slice of bread, and then smush it together. PBJ, x times 3 is 3x. And last but not least, we have another grouping one. So I'm going to go set up my area model and I'm going to dump everything into it. And go ahead and look for a GCF. So greatest common factor between x to the third and 6x squared is x squared. And then x times x squared would give me x to the third. X squared times 6 gives me 6x squared. And x times -1 gives me the negative x. -1 times 6 gives me -6. So I have a base and I have a height, but notice that x squared minus 1 is the difference of squares. So that will factor into the conjugates x plus 1 and x minus 1. If you need a refresher on that, please go check out my Algebra 1 playlist. You should see a video that is entitled like special case, difference of squares. I would have recorded it several months ago, so I don't remember now exactly what it's titled, but like you should be able to find what you're looking for. Okay, first 4 are done with plenty of space. All right, so these next 2, so the first one is pretty straightforward. This is a difference, or sorry, not difference, it's a sum of cubes. And we're gonna do same, opposite, always positive, and ask ourselves, what to the third power gives me 8? Well, that is 2. What to the third power gives me x cubed? That is x. You're going to keep them both on the left side of the parenthesis there. And then, oh, a bigger number. What to the third power gives me 125? That is 5. If you need to, if you get thrown numbers that are much bigger, you would just grab a calculator and probably just check, okay? Now we're going to make our sandwich. So we're going to take 2x. Now 2x, when you square it, it's 2x by 2x is going to be 4x squared. Make sure that you are squaring the entire thing. 5 squared is 25. And then we're going to smush that together. 2x times 5 is 10x. Now this second one might have thrown you for a loop a little bit. It says do it 2 different ways. So you might be tipped off that this is indeed a difference of cubes. And so you might go straight here, okay? You do same, opposite, always positive, and then ask yourself, okay, what to the third power gives me 8? That's 2. And what to the third power gives me x cubed? That's x, same as what we had over there. And then what to the third power gives me 64? That is 4. And then we're going to square it. So that's the 4x squared, did that right there. And then we're going to square the other one. 4 squared is 16. And now we're going to smush it together. 2x times 4 is 8x. But the directions to this said completely factor. And when I get this completely factored or factored this far, I can see that it is not completely factored because I have all even numbers there. So what I need to do is factor out some common factors. So in this first factor right here, I see 2 and a 4, and those are both even. So I can factor out that 2, and it'll leave me with x minus 2. Okay, we can do a quick multiplication through 2x, 4. There we go. Now, over here, I actually have a GCF of 4. Okay, 4, 8, and 16. So remember, this is multiplication. So I'm going to take out that 4, and I'm left with x squared plus 2x plus 4 right there. And so now I've got 2 times x minus 2 times 4 times x squared plus 2x plus 4. And these are both constants outside, so I could do 2 times 4. And that's going to give me 8. And I have x minus 2, and then the x squared plus 2x plus 4. Okay. Now, if you started to do that problem that way and you just were like, well, it looks completely factored to me, make that correction on your work. Like, crud, I got to look for a GCF, right? Because we cover looking for a GCF at length, when we first start factoring, and then we just don't talk about it that much anymore. And you might see problems of this type that don't have a GCF, or we just don't throw one in. Now, the real challenge here was to do this 2 different ways. So the other way you could do it is to recognize at the beginning that there is a GCF of 8. Okay, and so we can factor out that 8. That's going to leave us with x cubed minus 8. And now we can factor the x cubed minus 8. So that's a small parenthesis and a big parenthesis. We're going to do same, opposite, always positive. X to the third power gives you that x cubed. 2 to the third power gives you 8. And now we're going to square the x. We're going to square the 2, and then we're going to multiply the x and the 2 together to get the filling. And don't forget, we have that 8 is sitting outside. Now you can take a moment here and think which of these two ways was easier. They both work, okay? So you can do the difference of cubes and then get the GCF out. That totally works. Or you can get the GCF out at the beginning and then do the difference of cubes. It's kind of whatever works better for you. I think it's easier to spot the GCF first, because then when you're doing your difference of cubes, you're working with smaller numbers. But both ways work, and I just wanted to draw your attention to the fact that there is more than one way to do this and give you some options for like, what do you think is the better way? I think it's less error prone if you go and get that 8 at the beginning. My own hot take though. Okay, so at this point in the problem writing, true story, I just got kind of bored and I thought these factoring by grouping problems are way too simple. That portion of the video is like a whopping 6 minutes to cover it because it is so straightforward. So I thought, what can I do to make these more interesting? So let's go ahead and dump this in. So this does look a little bit different because it's got some coefficients and stuff in there, but the strategy is still the same. So you can pick whichever direction you want to go in. I kind of like factoring in this direction, and this is one of the reasons the area model is so good. If you do it with the alternative layout that I showed in the video, you have to work with the 3x to the third minus 9x squared, which means you've got to work with a GCF with the numbers. The 3 and the 9 have a common factor of 3, and you also have to kind of navigate around a negative and hope that you're doing that right. If you put it in the area model, you can start this way. 3 and 4 do not share a common factor, and there's no negatives. So you're really only looking for the GCF between x to the third and the x, which is just an x. And that gives you your starting point. So this would make that 3x squared there, and this would have to be a 4. And then this would have to be a -3, and you can kind of check all of those. So x times 3x squared, -3 times 3x squared, x times 4, and -3 times 4. And so our base is x minus 3, and our height is 3x squared plus 4. And you would want to check that and make sure like you can't factor it anymore. Next one. So we set this up. We have 4x to the third plus 8x squared minus x minus 2. And I think it's kind of a toss-up whether I want to factor up this way with like the potential negative, or this way where I've got to deal with the numbers. I kind of like this way because I don't like the negative. So GCF there is 4x squared, which makes that the x, which makes that a 2. This must be a -1, and 2 times -1 is -2. So my base is x plus 2, and my height is 4x squared minus 1. But that right there is the difference of squares. And so we can factor that into conjugates. So this would be 2x plus 1 and 2x minus 1. We look for like what squared gives me this instead. So check that. That is something that I might anticipate a student missing, especially with the coefficient in front of the x squared. Makes that one a little bit like sneakier there. Okay, now for these last two, I was like, well, let's do something that's not even a cubic. Let's play around with this some more. So on this one, we have x to the fourth, -x to the third, 8x, and -8. And I'm going to go with my GCF this way. The greatest common factor between x to the fourth and 8x is just a single x. which means this will be x to the third, which means this must be -1, which means this is 8, and that's -8. So I get x minus 1 and then x to the third plus 8. Oh, but wait. That is the sum of cubes. So that is going to factor into the small parenthesis and the big parenthesis. We're going to have same, opposite, always positive. I think we've done this before. It's like either in the lesson or earlier in the practice set. What to the third power gives you x cubed? That's x. What to the third power gives you 8? That's 2. Square it for one slice of bread, square it for the other slice of bread, multiply it together for the filling. And that's your complete factorization. So that one dumped out with a sum of cubes like in it. Yay. And I think this one is even more fun. I think this one has like everything dump out in it. So let's take a look. This is x to the 5th. We've got -x to the third, -x squared, and a +1. And I'm just going to go ahead and say, okay, my GCF between x to the 5th and x squared is x squared, which means this is x cubed, means this is -1, and this is -1, and -1 times -1 is +1. And this one, when I go to write it out, I have the difference of squares on the left and the difference of cubes on the right. So we are just pulling out all of our factoring stops here. So what do we have here? This will factor into the conjugates x plus 1, x minus 1. My cubes are going to factor into a small parenthesis and a big parenthesis. We're going to have same, opposite, always positive. X to the third power gives you x cubed. 1 to the third power gives you 1. We're going to square the x. We're going to square the 1, and then we're going to smush it together. Now, what I notice in doing this is I actually have this factor that appears twice. So what you might see, okay, is this. You could see the x plus 1 and then the x minus 1 squared like that, just showing that that factor appeared twice, and then our trinomial out there. Ta-da! Okay, so that was a lot of fun. Check and see if you did not get all of them right. Like, where did you make mistakes? Did you make mistakes with pluses and minuses? Was it part of the SOAP acronym? Was it knowing how to find a GCF? Did that part throw you? I am assuming in this video that you know how to factor the difference of squares, but maybe you don't. Maybe that is a skill you've forgotten, okay? So make sure that you're identifying where in the doing of the problems that you're making mistakes or getting stuck or didn't know what to do next. And that's the where you want to focus, and that's the kind of question you want to bring to your teacher. So that is that. Please don't forget to like and subscribe if this video was helpful for you. Drop a comment or ask a question below, and check out the many other videos that we have on the channel. I hope to see you in a future video.